So the last one here, dividing complex numbers. When we talk about is a fraction simplified, there are a few things where a fraction is not simplified. One of them, if I had 10 over 20, you could divide out the common factor and have 1/2. Okay, then if we have negative exponents, those are not considered simplified. We've dealt with square roots in the denominator. That's not simplified. Also, imaginary numbers in the denominator, not simplified. So as soon as I see negative 3i over 4 minus 4i, what comes to mind is I can't have an I in the denominator. It's not considered simplified. Roots in the denominator, like square root of 2 or an I, not simplified. So to get rid of i's in the denominator, you can multiply by its conjugate. And the conjugate, the only symbol that changes is the i's. If it's a positive, then it's a negative. If it's a negative, it's a positive. But the number in front, you don't change the sign on the number A, only on how many i's you have. Okay, so for this one right here, my denominator is 4 minus 4i. So the conjugate to 4 minus 4i is going to be 4 plus 4i. And when we multiply the denominator by its conjugate, all the i's are going to go away. But what I do to the bottom, I've got to do to the top. All right, so I'm going to go ahead and, oops. I'm going to multiply the numerator and denominator by 4 plus 4i. For myself, I don't like to work across too long because it just starts going too far. So I'm going to multiply the numerators together and kind of write that up, and multiply the denominators together and write that down. Also, I might, just for notation, I'm going to put a set of parentheses around the previous numerator and denominator, just to emphasize what we're doing. Okay, so negative 3i times 4 plus 4i, that requires distributive property. So negative 3i times 4 is negative 12i. And then negative 3i times 4i is negative 12i squared. This I squared is equal to negative 1, and I'm not going to show that this time. I squared is negative 1, so this is negative 12 multiplied by negative 1. Yeah, positive 12, very good. So the negative 12i still there, and then that's 12. Okay, then let's multiply the denominators together, and we're going to have to FOIL. So 4 times 4 is 16. Then on the outside, 4 times 4i is 16i. And 4 times negative 4i is negative 16i. So we have positive 16i and negative 16i. And then last times last, negative 4i times 4i is negative 16i squared. A shortcut, you don't have to remember this. If you FOIL, you're going to be fine, but every single time you multiply conjugates together, you can skip O and I in FOIL because they will always cancel each other out. If I would have done 4 times 4 and gotten 16, first times first, skipped O and I and did last times last, negative 4i times 4i is negative 16i squared. See how these middle ones are going to cancel out? So, and if you forget, no big deal. You just end up saying those are gone. All right, then that I squared is negative 1. So negative 16 times negative 1 is plus 16. So I have a plus 16, and out front I have a plus 16. So 16 and 16 make 32. I'm gonna go ahead and remove this one step. I think that's maybe a little bit too much explanation. Okay, so just 16, this is plus 16 because negative 16 times negative 1. Okay, then I'm gonna go ahead and rewrite what we have. So in the numerator right now we have negative 12i plus 12, and in the denominator we have 32. We need this to look like a plus bi. This denominator 32 belongs with each one of these. Like we're undoing adding fractions. So if I put the 32 with each one of these, I have negative 12i over 32 plus 12 over 32. Just think about undoing that. If I went this way, if you were adding fractions and the denominators were the same, you would combine the tops over the common denominator. So we're just pulling those back apart. We're getting that a plus bi look. Now this fraction simplifies 12 and 32. So 4 fits into 12 3 times, and 4 fits into 32 8 times. So I'm dividing the top and bottom by 4 to make this negative 3i over 8. I'm dividing the top and bottom here by 4, and 12 divided by 4 is 3, and 32 divided by 4 is 8. Now it looks pretty good, we're getting close, but to focus on that final format, a plus bi, this is a number, and these are our i's. So I'm going to take these and change the order, just like 2 plus 5 is the same as 5 plus 2. We can move those around. So I'm going to write that here. And so I have 3 eighths minus 3 minus 3i over 8. Now I put the I off to the side, and the reason I can do that is this I would be over 1. Numerator times numerator, denominator times denominator. If I took 3 times I over 8 times 1, I would have my 3i over 8. That's why we can put the variable on the side. And the reason I'm doing that is my A is 3/8, my B is negative 3/8 I, A plus BI. We can see clearly the A and the B. All right, so we should probably do a couple more of these.
Wait, do those numbers end up the same, like 3, 8, 8?
They won't always.
Okay.
Yeah, it's a coincidence on this particular one.
I know I
Yeah. Okay, so I've got just 2 more at least to get them started. Your thought process again is, I see an I in the denominator, and fractions with I's in the denominator are not considered simplified. So to get rid of an I in the denominator, you multiply by the conjugate. Okay, so my denominator here again is negative 1 plus 6i. You only change the sign on the i's for your conjugate. So the conjugate is negative 1 minus 6i. I'm going to multiply by negative 1 minus 6i, but whatever I do to the bottom, I've got to do to the top. You may want to put a set of parentheses to help you multiply, because you're taking numerator times numerator, which you would need to FOIL, and denominator times denominator, and you would need to FOIL that. I'll come back in a moment if you want me to finish that one out, but getting it started, being able to FOIL those together. Okay, so this one right here, for the conjugate on 5i, a plus bi changes to a minus bi. So here we have that 5i is the same thing as 0 plus 5i, so that we see the a and the b. So we're only changing the sign on the i's. So the conjugate of 5i is 0 minus 5i, which is the same thing as negative 5i. So we multiply the denominator by the conjugate to get rid of the i's, but what I do to the bottom, I do to the top. I'm gonna go ahead and put parentheses around the original numerator and denominator. When I multiply the numerators together, I'm going to distribute. So negative 5i times negative 2 is positive 10i, and then negative 5i times 2i is negative 10i to the second power. So negative 5 times 2, negative 10, I times I squared. In the denominator, 5i times negative 5i is negative 25i squared. I'm ready to go in and replace these I squareds with negative 1. So negative 10 times negative 1, that's going to make that plus 10. And negative 25 times negative 1 is going to make that positive 25. The 25 belongs to each one. So I have 10 over 25i plus 10 over 25. 10 over 25 simplifies to 2/5 when I divide top and bottom by 5. But I want my i's at the end to make it look like a plus bi. So I have changed the 10 over 25 to 2/5 in both of them, but put the i's on the end.